about matrices first. What are all matrices? Matrices are nothing but the mathematical structures which is going to give you the representation in a very proper and in a compact form. So it is very important to deal with the matrices, and hence it is quite essential that an engineer is supposed to know how to deal with the matrices. And also just check out with the applications that is related with the matrices, and thereupon the characteristics of the matrices and the ideas about the matrices like eigenvalues, eigenvectors. So what are all the possible applications, how it can be implemented in the engineering applications. So to deal with all these things, it is very essential that students have to know the idea of dealing with the matrices with a very basic depth knowledge. That's why in this unit we will deal with the idea of the matrices in a proper, cohesive and very elaborate manner. So first we will just go with the content of this unit 1. We have to deal with the characteristic equation of a matrix. Next comes the Cayley-Hamilton theorem, eigenvalues and eigenvectors of real matrix, properties of eigenvalues, eigenvectors, diagonalization through the orthogonal transformation, and thereupon we will move on to the reduction of quadratic forms to canonical forms by orthogonal transformation, and finally we will proceed with the application part. Now, definition of a matrix. First let us try to discuss the definition of matrix. Matrix is nothing but a rectangular arrangement of numbers or functions, and as you know, the rectangular arrangement is going to have the rows and columns, and here the order of the matrix is denoted by m cross n, meaning that there are m rows and n columns. There are m rows and n columns, and the way we denote the elements of the matrix follows with this suffix notation. Say for example, A11 refers to the element in the first row and first column, whereas A23 represents nothing but the element in the second row and third column. So that's how the elements of matrix will be represented. And the another short form of representing the matrices is Aij within this bracket, and for I and j the range could be given like 1 less than or equal to I less than or equal to m, comma 1 less than or equal to j less than or equal to n, or simply it can be treated as Aij. Now let's go to different types of matrices. So what are all the different types of matrices that we will come across is, first one is a very special matrix which is called the square matrix. So in a matrix the number of rows is equal to the number of columns, then that matrix will be called as a square matrix. So the name is just because it will look like a square. And a row matrix is a matrix which is going to have only one row, whereas the column matrix is going to have only one column. So these types of matrices will arise in the engineering field very often. And continuing with the types of matrices, diagonal matrix. So it is a very special type of matrix and a compact form of representing a matrix with a large number of entries. So in a square matrix, if all the elements except the main diagonal are zeros, then that will be called as a diagonal matrix. Example for this could be, consider the matrix of the form 1 0 0 0 4 0 0 0 5. So this is an example of a diagonal matrix. So only the diagonal elements must be non-zero, whereas all other off-diagonal elements must be 0. Next is the unit matrix or the identity matrix. A diagonal matrix, it is a diagonal matrix in particular if all the diagonal entries are 1. So, if you just impose the condition on the diagonal matrix in this manner, then that will become the identity matrix. And the next one is the upper triangular matrix, where you are going to have the non-zero element only above the main diagonal. So, in that case, an example can be this matrix 1, 2, 3, 4, 0, 5, 2, 6, 0, 0, 3, 1, and then 0, 0, minus 1. This is an upper triangular matrix. Similarly, we can define lower triangular matrix also.